So what we just did was we changed the f of x to y. Because what I'm going to do now is I'm going to change it from log function to exponential. What's the base of the log? 3. 3 to the... 3 to the y. Right? So now I need to make my xy chart. Now, should I fill in the x's or should I fill in the y? Right, because I can do 3 to the y. So what numbers do you want to pick? Good. So go ahead and fill those in. And if I plug in -1, I should get 1/3. If I plug in 0, plug in 1, plug in 2. How many of you got those numbers? Good. So if this was an exponential function, if it was 3 to the x equals y, my asymptote line would be what? Y equals 0. But since it's a log function, it's no longer y equals, it is x equals 0. So my asymptote line is x equals 0. So log functions have the asymptote line going vertically instead. Exponential have them going horizontally. Does that make sense? So we're going to plug in our lovely asymptote line. And we're going to plot our point. 1/3 on the x, down to -1. We'll go to 1 on the x, and we're at 0. Over to 3 on the x, we're up to 1. Over to 9, we're up to 2. And there it is. Now, a little crazy thing. What's my y-intercept on this one? What? There isn't one. There is no y-intercept. It can never touch this y-axis, right? Because that's an asymptote line. Let's do domain and range real quick. Domain are my x's, right? Domain are my x's. Well, what's the smallest x value here? 0. And can I be equal to 0? Nope, just greater than, right? Range are my y. All real numbers. For logarithms, yes. If it was exponential, guess which one's always all real numbers? Domain. Look, they just flip, don't they? No tricks here. How do you feel with that one? Happy? Okay. Let's do a harder one. Log base 3 of x minus 1. Go ahead and glue that in. Write that down, and then stop because we're going to talk about it. So first thing I'm going to do is change g of x to what letter? Y. Now, I can't change it yet to exponential. See that -1 at the very end? I need to move it over there. How do I move 1 over there? Okay. So I have y plus 1 equals log base 3 of x. Now I can change it to exponential, right? So it'd be 3 to what? 3 to the y plus 1 equals x, right? Hey, wait, now it looks like those exponential functions we've been working on so much, right? Okay, what's the base function? 3 to the y. So guess what I need to make now in order to graph it? The what? XY chart. What numbers are... Oh, where am I filling in my numbers? In for y. And hopefully you can fill these in very quickly. Mainly because, wait, there's the exact numbers we filled in already, right? Go ahead and graph those points. What's my asymptote line? Well, you were close with 0. You were very close with 0. But 0 is just the point. X equals 0. I wasn't trying to trick you, but that sounded mean, didn't it? I know. I know. All right. Now, so now we have to reverse everything in our heads, right? Okay. Like before it was y equals 0. Now we have to reverse. Oh, sorry. Before it was y equals 0. No, no. When we're doing exponential, it was always this way, right? Now since we're dealing with logarithms, we have to reverse it. It now becomes. Does that make sense? Okay. So plus 1 used to move this which way? To the left one, right? So let's reverse that. So instead of moving it to the left, how about we move it down? Because left is now going to be down, up is now going to be right. We're just reversing left and right with up and down. Because what we're doing is flipping things, right? Does that make sense? Left and right now become up and down. Because we're backwards. So all of my points now are going to move exactly down 1. Switch the sign. Now, the what? Right, so now we have to switch it because it's actually dealing with, does that make sense? Because that's the letter Y, so instead of it dealing with the X, it's now dealing with the Y. Does that make sense? So what if there had been a number on the outside for some reason? Plus 2. Let's pretend there was a plus 2. That would actually do what to the graph? Move it right here. That's all you think about. Okay. Let's do another one. So here's our next problem. Now, is there anything added or subtracted at the end? No, nothing at the very end. That x plus 2 is on the inside of parentheses. So it doesn't count because the log is being taken with that. So in this case, I get to rewrite it as 3 to the y equals x plus 2. Because I don't need to move that 2 over like the other one. See how on this one, it didn't have the parentheses, did it? So the log didn't go with the 1. On this one, it does go with the 2.
So, does it go?
Over to the other side. Let's move it to the other side.
No. No. Whenever you do this, you start with your y, right?
Yep, I'll change it.
Okay. You go to your y, and then you go to your x plus 2, and then around to 3.
Start with the 3.
Okay, why?
That's your base. Log base 3. So your
I
base.
thought it started this way, one here, and then underneath.
That's if log was over here, it would start that way. It's whatever the base is with the log. So I do need to move the 2 to the other side, so I would. So 3 to the y minus 2 is equal to x. Base function? Okay, make your chart.
Are you always plugging in your x y plus to your base function?
Yes.
Only your base function?
Yeah, because otherwise you have to figure out what it is without the calculator when we take our quiz, and I don't want that to happen. It's easier if we do that. Now, hey Jax, you were right. Remember when I said plus 2 and you said go to the... You'll see here in a second. I messed up on the last slide and you were right. Okay, she's like, wait, what? Okay. So before we do anything else, let's write our asymptote. X equals, and what's my number right here? Negative 2. Since it's here, I don't change its sign. Remember, if it's up as an exponent, you change the sign, keep the sign, right? That process still works of change the sign, keep the sign. So x equals -2. Let's go and put our dotted line on. Plot your points. 1/3, -1, 1, 0, 3, 1, and 9, 2. And that -2 moves the whole graph to the left 2.
So when it's in the exponent, you do that.
Yes. Let's write ourselves a little note right now. Exponent for logarithm, move it up or down. Numbers on the outside, move it left or right. And exponents, we always do the opposite. So if it had been +1, we move it down. But the number that's not in the exponent does actually what it's supposed to do. Moves it left 2. We're actually going to do domain and range with this too. Now you know another way to get it? Switch this sign. That's another way. Domain. Good. By the way, your asymptote line and your domain for these will always have the same number in them. Your asymptote line and your what will always have the same number if it's just a regular exponential function. And the range. Yep. In this case, what's the range? All real numbers. You laughing at my R. It is kind of a funny R. Alright. Okay. I'm giving you some of this time right now to finish the essential work and actually hand it to me today. I'm going to hand you a worksheet that we're going to go over tomorrow.